And we can just mention that Daniela hasn't been responding the thing to the message board that we've been doing, and so we're not sure why she's not on right now. But if she gets on later, then she'll get credit for it.
Yeah.
Okay. Well, let's go over it real quick then, because it's pretty simple. It's not a lot of computation. It's more of the principles for this lesson.
Concepts.
Yeah. So, did you pull up the answer key and the preparation?
Yeah.
Yeah. So, I mean, I like looking at the answer key to see how they say it, but then to say it in our own words too. And I watched a video. I watched one of the videos this time, and it made a lot more sense, like why it's important.
Yeah, the videos they have are actually pretty helpful.
So number one, what is a confidence interval? Basically, it's like it sets the bounds for where you think samples can come in. Like it says, we think that we're confident that any new sample is going to be between this and this.
These two values.
And yeah, and the way that it says it in the answer key is just an interval of numbers which estimates the population parameter. That's the word I'm looking for, parameter. So it sets the parameters for your population, where the majority of your samples will lie. And then two, what is the margin of error in a confidence interval when estimating the population mean? Margin of error is, it's not the standard deviation, but it's like we think that this is the average plus or minus however many units you're talking about.
Yeah, the answer says it's half the confidence interval.
Right. So up and down the confidence interval, or up and down half the confidence
interval says it's between like 5 and 50.
Yeah.
Your confidence interval is, a value of like 22.
Yeah, it's like half that. Hey, hi. Daniela.
Hey, what's up?
How are you?
Good.
Great. How are you?
Fine, thank you.
So we're just going through the prep right now. We're on number 3.
Okay. Calculation mean. So I answered that. It's well, assuming you know the standard deviation, sigma. What is the general formula for a confidence interval used to estimate the population mean? So it's this one, right? I'm going to show you. Can you see or not?
I think I can see well enough. Yep.
It's that one, right?
Yes.
Yeah, so it's x plus or minus z times the standard deviation over the square root of n.
Right.
Yeah.
Awesome. And then number 4, what are the assumptions for creating a confidence interval for a single mean with known sigma? So when you know, one of the assumptions is that you know the probability of committing a type 1 error, or you know like the probability, like your confidence level, I guess. Yeah, and then you also assume the population is normally distributed and that a statistic was pulled from a simple random sample.
Yep.
Okay, 5. I'm going to open the applet.
This is in the book, so I think A, B, and C are the most common use values for C.
Right.
So for 90, is 1.645.
Uh-huh.
The other one is 1.960.
So when we say numbers after the decimal point, we don't say 100.
We
So you can just say 1.649 and 1.960.
okay.
Yeah.
Okay.
Uh-huh.
Thank you. And
You're
the
welcome.
other one is 2.576.
Perfect.
See?
Awesome.
So
Yeah.
as the area under the normal or the middle of the normal curve, as it increases, the z-score gets bigger.
Right. Or like we learned it before because we were using it the other way. As the z-score increases, so does the area under the curve.
Yes.
Cool. And then part 2, what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean?
Same as 4.
Yeah, okay, good.
Simple random sample, normal distribution, and sigma is assumed to be known.
Right. So, and the sigma just means like the probability of committing a type 1 error.
Mm-hmm.
Okay. So let's do 7, or I'll read the prompt. The GMAT is used as an admission criterion in many Masters of Business Administration programs. A BYUI professor would like to estimate the population mean for a simple random sample of 50 people, 50 people score. So n equals 50. The sample mean for these 50 students is 541. So X bar is 541. Assuming the population standard deviation of 32. Answer the following questions. What is the point estimate of the population mean?
541.
Yeah. 541. So 541 is not S bar or X bar. It's actually just that U, that weird looking U. Okay, and then
The mean.
create a 95% confidence interval for the population mean. So then you
just put
541 plus or minus. We have 95%. So what was that number again? It was like 1.96.
The z-score is 1.96.
1.96 times 32 over square root of 50.
Yeah.
Okay. And I can plug that in real fast. Unless, Daniela, did you already plug it in?
Money? What?
Asked it, did you already do number 7? Do you have, or number 8? Do you have that number?
I don't do it. No, is it?
You didn't do it.
No, I don't. No, is it? No sé cómo se dice. I didn't. I didn't do the second part.
Okay.
Let me grab a calculator. I got it.
Yeah, I just got it though, but you can do it too. Probably better that way.
Sorry, you got it.
Okay. So I ended up getting. 1 second. Let me do all of them. 9. I have between 532.13 and 549. And the way I did that was I just did 1.96 times 32 over square root of 50. And then I did 541 plus that and 541 minus that.
Awesome.
And so let's look at the answer key.
That's it. Yeah.
Okay.
And
those are the bounds.
And 100, compute the 95. Okay, so you just switch 51
make it
with 100.
So 32 over 10 times 1.96, and then 541 plus that. And so the top bound is 547, and 541 plus or minus 6.272. That's 534.7.
That's it.
And that just shows that as you increase your size,
Mm-hmm.
you can become more confident that your numbers will be closer to that.
You decrease your margin of error.
Right. That's right. Okay.
How does the margin of error for 95% confidence interval? So, okay, great. We just answered that.
Right. So you decrease your margin of error.
Mm-hmm.
Right.
It's inversely related.
Mm-hmm.
Okay.
And then 12, how does the margin of error for 95% confidence interval, so you computed in question 8, compare the margin of error for 90% confidence intervals?
Yeah, I'll do the 90 right now. Was it 1.9 or 1.
It's 1.6, no.
No, it's
What's the z-score again?
1.645.
1.645. Okay. Times this, and everything else is the same, right?
Yeah.
Except for 50 students. Okay.
Mm-hmm.
And then 541 plus or minus. Okay. So that is 0.2. Okay, you're right. Okay, so for that one, it's between 533.55 and 548.44.
Yep. Mm-hmm.
Okay. And then, so compare, how does the margin of error, so you can be more confident that you're going to be, hold on, what was our margin of error for the other one?
Our margin of error for the, what, 50 sample size?
Yeah, for 95% at 50.
Is 532 to 549.
Okay, so this has less margin of error.
Our margin of error shrunk.
Yeah, so this one's 533, so it's a whole like 1 point, or I guess it's 2 points
Mm-hmm.
different. So how do they compare? What is it saying that if you're 95% confident that you haven't committed a type 1, or you're 90% confident you haven't committed a type 1 error, which gives you the 1.645 z-score.
So you have 95% confidence, and that gave you a larger margin of error.
Oh, right.
So
yeah, okay, you're less confident that it's going to be closer together.
Yeah.
Okay, that makes sense. Okay, the BYI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure the margin of error is 5. How many students will need to be in his sample to ensure that? Oh, geez, Louise.
It's the same standard deviation?
Yeah, so it's going to be the same confidence level.
Yeah, I think.
So I think it's supposed to be 95% again.
So we have to shrink the.
Yeah.
We have to shrink the
Just by increasing the sample size.
Mm-hmm.
So so it's 1.96 is what we're using. So I'm gonna just do like 1,000 and see what that does. 32. I bet we could do it.
Oh,
You did
we
it?
need to use. Yeah, I think it's 36 point as this. Can you see?
Mm-hmm.
Hold on one second. Show me again.
What is that number for?
I use the formula, the sample size calculations. Sample size formula is this one.
Oh, to get 5.
Mhm.
Well, I checked the answer key and it says that you need 158 students.
100. Oh my gosh, I don't know.
And we want 90.
Okay.
90.
So
Yeah,
you got to put x under the square root. So it's 541 plus or minus 1.96 times 32 over the square root of x.
so if you did, so what you could also do is like you could go 1.96 times 32 over square root of n equals 5. So then because you want to have that be 5. Then you divide 5 by 1.96,
Mm-hmm.
and then you find that number, and then you have to flip the whole thing around. So then you have the square root of n over 32 equals 1.96 over 5. And you times the other side by 32. 1.96 over 5 times 32. I'm going to see if this works. That should algebraically work. So 1.96. That. Hey, it totally worked.
Yeah.
Yeah. So when you times 1.96 over 5 by 32, and then you square it, because you have to get rid of the square root of n,
Yeah.
it comes up with 157.35.
Awesome. So you need at least 158.
Yeah.
so how do you? I don't understand that.
Okay. So let me see if I can. So so we started with 1.96 times 32 times 32 over the square root of 50. Right?
Uh-huh.
So Daniela, what is the margin of error for that? If you just compute those, so put that in a calculator and tell me what you get.
Okay.
Do you need the card just to show? Right on the table.
So it's 1.96. What is the number?
So 1.96 times 32 over square root of 50.
50. I get 8.869.
Awesome. Okay. So what does that number mean?
This is the division. No, the
margin of error.
The margin of error.
Yeah. Okay. Perfect. So that means that when you have 50 students, that's your margin of error. So the question is, how many students do you need to get 5?
So you need to use this and use the other. Use this thing. This formula. No?
Oh, yes, you do need to use that.
Okay, okay.
Yeah. So, yeah, so plug that back in and see what you get.
Mm-hmm.
Because that's what I did. I just didn't do it with the formula.
Okay. Mm-hmm. I get 11.46.
So that means that you need to do your calculations one at a time. So do, what was it? You got to do 1.96 times 32 divided,
Times 22.
divided by 5.
Oh, yeah.
Yeah, and then square that.
The,
So
the
times that by
formula is times, not. I know why.
okay.
I wrote the formula wrong. I have my formula. Yeah. Yeah,
Okay,
yeah.
so what number did you get?
It's. Give me a minute. Oh, 7.
No. You should get, it should be 158.
So it's you need to put 1.96 times 32.
Right.
Divided by the number that we get the last time.
No, divided by 5.
Mm-hmm.
I think. I hope I'm doing it right.
Yeah. It's 157.3.
Awesome.
Right, and so you can't have 0.3 of a person, so it's just 158.
Mm-hmm.
Okay. All right, let's get started on this quizzy.
Yeah.
So, number 3, the margin of error for 90% confidence interval, the standard deviation of 50 and an N of 25. So I got 1.645 times 50 over square root of 25.
Times 50, yes, over square root of 20, over 5.
So that's 1.645 times 10.
Right.
Which is 16.45.
Looks right to me. Hey, and Daniela?
Mm?
The
Wait.
number 1 and 2 are true.
Yeah, my computer is so slow.
Oh no.
Oh.
So
Okay.
in the quiz.
Well, we'll wait for you to get in.
Okay, I am in the quiz.
Okay, number 1 and 2 are true.
Mm-hmm. Yeah.
It's a stupid joke.
Divide when the standard deviation is. Okay, we are in 3.
Yeah.
I know.
So walk us through 3 and tell us what you get.
Find the margin. Okay. It is. At 3.29.
Andrew and I got 16.45.
So the standard deviation is 50
So
divided by 2.
we didn't have an X to use. So what we did was we just took the Z-score for 90% confidence level, which is 1.645.
Like,
And then you multiply that by 50 divided by the square root of 25,
oh, the square.
which should be 10.
Yeah, 50 over the square root of 25 is 10.
Yeah.
So then 1.645 times 10.
Gave us 16.45.
Yeah, 16.45.
Perfect.
Now we could be wrong, but
We're confident.
who knows? 90% confidence.
Yeah.
4. I think 4 is the funny U is the point estimator for X,
Okay.
or is it flipped?
I don't know that answer. Where do we find that?
Well, we read about it, or we looked at it in the homework. It was in one of the homework things.
I think it's second one, right?
So the point estimate, so 7. The point estimate is, like, at least in our problem number 7, it was what the mean is.
Right, but if you have X bar though, then it's your statistic off of your parameter.
So it's the second one. It's X bar is the point estimator of the mean.
Yeah.
That's what I trust Daniela.
Mm-hmm.
Okay. So Gina wants to construct a 95% interval for GMAT score. She knows that the standard deviation is 113. 13. Sample size of n equals 64. Computes 526. Uses information for the next 6 questions.
1.96 times. All right, so for the high end, I got 553.685.
Oh, that's right.
Or the point estimate.
What is the point estimate for true GMAT
It should be 526.
If that's what we're saying, yeah.
What do you get?
Well, question 4 says that the X bar is the point estimator for U, right?
Mm-hmm.
Question 4. So if that's true, then what we're saying is down on the next question, the X bar is 526.
Oh yeah, 526.
Then what is the margin of error for 95%? Now, Andrew, you do what you were doing.
I get
The high end was 553.685, and the low end was 498.315.
Okay, so then we have to put that in. Oh, so what is the margin of error? That's without the 526.
Oh yeah.
I get 27 27.685.
Yeah, I got that too, but I don't know if that is half of it. You know, because that's half. That's you. You take 526 and you add that, and you take 526 and you subtract that. So is it times 2?
That's half. That's half of what we got in those parameters.
Right. So what's is the margin of error both of them?
Margin of error is from top to bottom. Your level
Right.
of confidence is half of it, isn't it?
Right. Level of confidence. So level of confidence is your p-value greater or less than your sigma, going back to last unit. So the confidence interval is what you just did.
Okay.
But so what is the margin of error for that? And I think it's going to be 27.685 times 2.
Oh, times 2?
Yeah, because margin of error is
So then wouldn't the margin of error just be 553.685 minus 498.315?
is that?
Let me try that and see what it gets. You multiply yours by 2 and we'll see what happens.
Okay, I got 55.37.
498.
And 6?
Yes.
55.37?
Yeah.
Yeah, that's what I got.
Okay, so
So is it half of that?
no, so sorry, I just went back to the homework and I was saying it wrong. The margin of error is half the width of the confidence interval. So it's 27.685 because the confidence interval is 55.37.
This doesn't say round to anything.
I'm gonna keep the 685.
I mean, if you have to round it to 28. The lower limit is 498.
498.315.
0.315, and then the upper limit is 553.
553. 553 point what?
685.
685. Okay.
What would happen to the width of the confidence interval if Gina increased the sample size or decreased?
It would decrease. Yeah.
Decrease.
Perfect. And Daniela, do you want to do 10?
What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
I think it would increase because she's saying that she's almost 100% positive that she will get the right answer, or she'll get an answer within her confidence interval. So in order to do that, you have to widen your interval. Because you're using
So it's increased?
I think it's increased because you're using a bigger z-score.
Yeah.
There are a rule like say if the sample size is right. No, yeah.
Okay.
So it's increased, right?
Yeah. Okay. Bright bulb, light bulb.
That's so stupid.
The company is planning a study to assess the average life expectancy of their bulbs. They know the standard deviation is 400 hours.
Oh, that's a pretty good standard deviation.
Yeah. 400 hours. They want a 95% confidence interval with a margin of 50 hours. So that's where we're using that one we did last time.
What sample size do they need? Okay.
So we need to use 10.
So it's 1.96 times
times 400
over square root
n
of n.
equals 50. So then algebra the other way to get n by itself. So it's going to be 50 over 1.96 equals 400 over n. And then you can just flip it all around and say that the square root of n over 400 equals 1.96 over 50, and times everything by 400, So then the square root of n equals 400 times 1.96 divided by 50. So then 400 times 1.96 divided by 50, and then squared is 245.8624.86.
Yeah.
245.862.
Round to the nearest whole number.
Whole number, so 246.
246.
Sí, 246.
Okay. And then next one. Okay, the mean salary of actuaries is 100,000.
The standard deviation is 36,730.
Okay. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a significance of 0.05, so that's a 95% confidence.
Mm-hmm.
So we're going to use the z-score 1.96.
Mm-hmm.
You collect a simple random sample of n equals 36 and find that the x bar equals 1. So that's a good enough sample. So what is the lower limit of the 95% confidence interval? So we're going to take 111,000 plus minus
1.96.
1.96 times 36,730 all over 6. So 36,730 divided by 6 times 1.96, and then 111,000 minus that. It do this. And 199.1. Oh.
I got the upper limit.
Okay, I got the lower limit is 99,001.
99,000.
Yes, that's the lower limit.
Oh, I used the wrong sample mean.
What did you get, Daniela?
The same. I get 99. This one.
Okay, so then it says so it says round to the nearest whole number, so it's 99,002.
Yeah.
Okay. So then Andrew, what if we do that? We'll say 11998.
You just swap the minus for a plus. It's 122,998.47.
Yes.
122,998.
One, 2, 1, right?
122,998 is 13.
Yeah, that makes sense. Because the margin of error is 1.96. Well, no, 36,730 divided by 6 times 1.96. So the margin of error is almost $12,000. That makes sense.
Yeah.
Okay. Cool beans.
And then the last one, what do you need to know for computing the confidence interval? You need to know that X is normally distributed. You need to know the standard deviation, and that the simple random sample is drawn from the population.
Yeah.
It's
all right.
above.
Yeah.
All the above.
I'll submit it, and you guys hold off. 100%. So you guys are good to go. Make sure you guys get 100 so we actually did get all the right
Yeah.
answers, so, or all the same answers.
Okay, I have a question. I don't have
Got it.
7.
7?
Okay, question 7. It is 498.315.
498.315.
Yes.
Okay. I get yeah,
Okay, awesome.
100.
We'll see y'all on Thursday.
Yeah. See you on Thursday.
Bye.